Hi, everybody. This week we're going to be talking about solving rational equations. We spent a lot of time last week on rational functions and breaking down the domain and finding intercepts and asymptotes and all that kind of stuff. Now we're going to look at solving equations, so figuring out where some rational function or maybe combination of functions is equal to some specific value. I just wanted to take a quick look at a fairly straightforward example to get a sense for kind of how these things work and the sorts of things that are going to come up. So we want to, in this example, find all x values satisfying this equation, negative 8x plus 16 all over x squared minus 7x plus 10 equal to 1. So again, we've got this rational expression with x is in numerator and denominator. We want to figure out where it's equal to 1. So the general idea here is going to be that because we're working with a rational thing, so a big fraction, the general idea is going to be that what I would like to do is get rid of the fraction to be able to solve. The way we're going to do that is by multiplying both sides by the denominator. Now we'll see later on that sometimes there's a little bit of setup stuff that we need to do before that, especially if we've got like more than one rational expression or more than one fraction involved. But we'll get to that in class. Big idea though, where can I write this? Big idea, make the fractions go away. This is kind of the first time that we'll be seeing this idea that to solve something, we're going to transform it somehow, like apply some kind of operations to turn it into a thing that we already know how to do. Here, that's going to be by, again, getting rid of these fractions. So I'm going to multiply, in this case, both sides by the denominator, x squared minus 7x plus 10. Now, when I do that, what happens on the left-hand side is that those just cancel because we're multiplying and dividing by the same thing. As usual, I can do something to one side of the equation as long as I do it to the other. And what we end up with is negative 8x plus 16 equal to 1 times x squared minus 7x plus 10. Now this, if you kind of look at what's here, we've got x terms on both sides, we've got constant terms on both sides, there's a quadratic term in here. This is a quadratic equation. We know how to solve these, right? This is the part where I say, what do we know about solving quadratics? And you all say, everything, right? I can practically hear you now. So what we're going to do is move everything to one side. I'm going to add 8x to both sides. This goes away. I'm going to subtract 16 from both sides. And we get x squared plus x minus 6 equal to 0 because we moved everything over to one side. So then we just need to solve that. Now, I'm going to pause on that, and we'll come back in just a second to that because there is one thing here that we want to be a little bit careful about, and that's that this original expression that we started with was different than this thing that we ended up, working with and needing to solve, right? This had variables in the denominator. This does not. There's an important difference in those two types of things, right? Polynomials are defined everywhere. They don't have any discontinuities or asymptotes or any of that kind of stuff. So this is going to work out to give me solutions, and whatever they are, they work. They're in the domain of the thing because the domain of the thing is the whole real line. This, however, is not defined everywhere. So one thing that we want to be careful about is to think about the domain of this original expression. So because it's a rational function, I'm going to think about the domain by figuring out where the denominator is equal to 0. sorry, it was minus 7x. There we go. So I'm going to figure out where that's equal to 0 real quick. This one happens to factor into x minus 2 times x minus 5, which gives me 2 and 5. So in other words, the domain is negative infinity to 2, 2 to 5, 5 to infinity. What that means, though, is that whatever else happens in the process of solving this, x can't be 2 and it can't be 5. So we're going to have to watch out for that as we solve and once we get solutions. Okay, so back to the actual problem at hand. So the stuff in pink there, that's sort of a side note. Keep that in mind. Let's keep solving this. X squared plus x minus 6, that factors as x plus 3 times x minus 2, or of course you can use quadratic formula. We're solving a quadratic here, so however you're comfortable solving quadratics, go about it that way. I picked one that I knew factored. And then x plus 3 would be 0, or x minus 2 would be 0, which gives me negative 3 and 2 as solutions. But again, when we look at these, if I try to let x be 2, because of what happened here, all the way back in the original problem, I end up with something, and I don't know what, and I'm not going to bother to check, divided by 0, which is, oh man, hang on, I got to circle all my stuff again. Okay, if I try to plug in 2 here, what I end up with is something divided by 0, which is still undefined, right? Now, negative 3 is not a problem because negative 3 is in the domain of this function, right? It's in the middle of this interval somewhere. 2, though, is a problem. The function is not defined at 2. So this doesn't work. This is what's sometimes called an extraneous solution, or you can think of it like a false positive. Like it shows up in the algebra because what we did is go from this equation that we started with, which was, again, like kind of new, right? Unfamiliar, something that, I wasn't really sure how to deal with. We did some manipulations. We multiplied by the denominator, and that let us transform it into this thing that I'm more comfortable with, right? That I know how to solve, and we did that. But the cost for that, for kind of going from a form I'm less familiar with to one I know more about dealing with, the cost for doing that is that we may lose some information, or maybe introduce some information that wasn't there to begin with. That can lead to this kind of thing happening. So we toss out x equals 2. X equals 2 is not really a solution. There's actually a discontinuity there. It's not in the domain of the thing. The other one is fine though, because again, it didn't show up as a 0 of the denominator. So that's our solution. So our solution is x equals negative 3. Okay, now again, we'll see more in class about how to deal with more than one expression, how we can figure out eliminating multiple rational terms separately. But this is kind of the idea of how this goes. You eliminate the fractions by multiplying through by the denominator, and then solve whatever's left over. But again, with this sort of like asterisk, this catch by it, that whatever we get as solutions have to work in the original expression as well. So you can either do that by figuring out the domain beforehand and then kind of checking them, or another way to do it would be to say, just write another way in case we're not 100% sold on why we threw out 2. Here was our equation. Here's our solution. let's call them candidates, maybe. X equals -3 and x equals 2. If I just think about checking those, if I plug in -3, I get -8 times -3 plus 16 over -3 squared minus 7 times -3 plus 10, which is 9 plus 21 plus 10, which is 40 over 40, which is 1, which is what we wanted to see, right? But if I try to plug in 2, I get -8 times 2 plus 16 over, sorry, not -2, 2 squared, 7 times 2 plus 10, 4 minus 14 plus 10. I get 0 divided by 0, which again means that the thing is undefined, right? The important part there is that this is not equal to 1, and so that's not really a solution, but this is fine. To me, I kind of like the idea of thinking through the domain first before I jump in to solving the equation, but if you like this better, this is fine as well. Of course, you can do all this arithmetic stuff in a calculator, right? And the main thing that we're looking for is avoiding this kind of thing, right? Dividing by 0 is still undefined. That's the thing that makes this solution not actually work. Okay, so there's that. Again, we'll get a lot more detail and work more examples and stuff in class, but that gives you an idea of what to expect. So thank you for watching. I will see you in class.